Hello everyone, my name is Li Hao. Today we're going to do Advent of Code 2020. Advent of Code is a series of programming challenges on the Advent calendar where from the day 1 until December 25th, on every day there's one mini programming challenge. And within the programming challenge there's part 1 and part 2. So solving each of the parts will give you 1 gold star. And at the end of the game, you'll get 50 gold stars if you clear all of them. Right, so today we're going to do day 11. So if this is your first time watching this video, well, you have missed day 1 to 10. Right, and do you know what that means? It means that you can watch them over here. Okay, click on the link, go. Okay, so today we're going to do day 11. And let's take a look at what is day 11. So day 11, the seating system. Well, your plan lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to that tropical island where you can finally start your vacation. As you reach the waiting area to board the ferry, you realize you are so early. Nobody else have arrived yet. By modeling the process people use to choose or abandon their seats in the waiting area, you're pretty sure you can predict the best place to sit. Because you're smart, you make a quick map of the seat layout, which is your puzzle input. The seat layout fits nearly on the grid. Each position is either the floor, which is a period sign, and an empty seat, which is the L, right? Or an occupied seat, which is a hash. Right? For example, in the initial seat layout, might look like this. Now you just need to model the people who will arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. While all decisions are based on the number of occupied seats adjacent to the given seat. One of the 8 positions immediately up, down, left, right, or diagonal from the seat. The following rules apply to every seat simultaneously. Right, if a seat is empty, there are no occupied seats adjacent to it, the seat will become occupied. If a seat is occupied, 4 or more seats adjacent to it are also occupied, the seat will become empty. Otherwise, the state does not change. A floor does not change, seat does not move, nobody sits on the floor. After one round of the rule, everyone sits in the example layout becomes all occupied. While after second round, the seats with 4 or more occupied adjacent seats become empty again. And this process continues 3 more rounds until at this point some interesting thing happens. Chaos stabilizes, and further application of these rules cause no seats to change state. Once people stop moving around, you count 37 occupied seats, or simulate your sitting area by applying the sitting rules repeatedly until no seat change state. So how many seats end up occupied? Right. So let's do this. So we begin with our puzzle input. Okay, let's save it. Let's input.txt file. Let's move it to day11.txt. And let's create code day 11. And let's start code day 11. Okay, so let's first thing first is to read the input, which we use file system from Node.js, where read file sync day 11, encoding with UTF-8. Right, so let's take a look at the input. So it's L or dot, but it may be, so with a hash which is occupied, right? L is the empty seat, dot is the floor, and hash would be the occupied seat. So let's break it down to a 2x2 matrix first. So doing that is to map, to split it by new line. And for every seats again, row, we're gonna split again. So this is the layout. Okay, I'm gonna use lets because probably we're gonna update layouts on every cycle. Okay, so now So while true, we're gonna have a new layout, next layout. Get next layout. Right, so every cycle we are going to get a next layout based on the current layout. And if next layout is equal, so if the current layout is equals to the next layout, then we've reached the end state, which is the seed changes stabilizers. Then probably we will count layouts, right? Count number of seeds for one layout or for the layout, right? And then we're gonna break the loop. So this tree function is what we're gonna implement, right? So we're gonna have function layout is equal takes to layout, next layout. So gonna do with the simplest first. Okay, so counts is nothing but count on every row and every column so that we get every seed. And we count how many seed that is a hash sign, which is occupied seed. So for let I equals to probably better naming, which is for row equals 0, row less than layout dot length, row plus plus, for let column equals to 0, column less than layout row dot length, column plus plus, and then layout row call equals to hash if then we have a variable called count equals to 0. So count plus plus. I'm going to return the count. Okay. And the next thing is whether layout is equal, right? So it's actually the same thing where I'm going to copy this for loop over. And I'm going to say that if next layout with the same row and column, if the value is not the same, then I'm going to return false. And if we couldn't find something that is not the same, which means it's the same, then return true. Okay. And let's get to the next layout. Well, over here, what we do is that we're going to create a new, the next layout. I'm going to return next layout. Okay. And we're going to do the same for loop as well, which will clean up whatever is inside. So for every row, we're going to create a new row array. So next layout row equals to a new row array. And over here, we're going to figure out what's the value of the next layout in row column, right? So it depends on two conditions, right? So the first condition is that if the current seed is empty, no occupied adjacent to it, it'll become occupied. Right, so if the layout row call is now empty, right, then probably we need to count the adjacent seats, right? So next layout goes to count adjacent seat, row, column, and the current layout equals to 0. Okay, adjacent occupied seat, right? Occupied adjacent seat equals to 0, then it will become occupied, or else it will stay unoccupied, right? Okay, and else if layout row column equals to occupied, then it's actually a different rule, which is if a seat is occupied, 4 or more seats adjacent to it is also occupied, seat becomes empty, right? So which means that copy this rule over. It's 4 or more, then it will become empty, or else it will stay occupied. Else, it's most likely that it is a full stop, which is the floor. Then next layout row column equals to a full stop, right? So probably with this, we figure out the next layout. So again, we have new function to fill it in. So we're going to fill this in. Function layout row column. Okay, so we're going to loop through all the directions, right? 8 directions. Top left, up. Top right, right. Bottom right, bottom left, left. Right. So usually what I like to do is actually I will create a directions array, which is a nested array of all the different directions. So minus one, which is top left, and then we have minus 1 0, which is top, and then minus 1 1, right? And then we have 0 minus 1, and then 0 0 is what we omit, and then we have 0 0 1, right? And then we have 1 minus 1 minus 1 0, and then 1 1, right? So let me align this a bit, and you'll probably see that hold on. Right, so this is all the 8 directions. Let me align this, right? All the 8 different directions. So I have this directions array, and I'm gonna use it over here. So for direction of directions. So now with the directions, we can actually know like what's the cell to look at. So row const row direction goes to row plus direction first, and column direction is actually column plus direction 1. Wait, so row is actually yeah, correct, right? And so if row direction is greater than, so we need now we need to know that whether the cell that we either the offset is actually still within the layout, right? It could be at the border, and the current row and column is at the border, and it could go out of that border. So we're going to know that whether this new row direction, column direction is within the bounds. So it has to be greater equals to 0, and row direction is layout.length less than the layout.length, and column direction is greater than 0 0, and column direction is less than layout row direction dot length, and all of that fulfills, then if layout row direction and col direction is occupied seat, then we're going to increment count. So we need to declare the variable count as 0, and we're going to use it over here. Okay, format it. Okay, right, so let's run this. Oh wait, sorry, an extra comma over here. Let me clean this up and run this again. And okay, I think we're running the infinite loop. That's because, well, after, if it's not equal, then actually we need to set the layout equals to the next layout so that we can move forward. Okay, so that we compare the next layout, we compare whether the next layout is equal to the current layout. If it does, ends, we count the layout, number of occupied seats. If not, then we update the layout as the next layout, and then we continue this again. So let's clear and run this again. 2281, that's a number, and we're gonna copy it, and we're gonna try and see. That's the right answer. Yes, so one more gold star down, and let's go to part 2. So as soon as people start to arrive, you realize your mistake. Oops, we make a mistake. Well, people don't just care about adjacent seats, they care about the first seat that they can see in each of the 8 directions. So it's not just right next to you. If in front of you is if it's a seat, then you will consider. But if it is a floor, then you will look forward and forward and forward. So the first seat that you see within that direction will be considered. Right? So in this case, actually all directions are occupied, right? So L looks forward, there's a hash, looks diagonally, looks horizontally, diagonally, top left, bottom right diagonal, horizontal, top right. Okay, all directions. And well, the empty seat below over here, L, actually will see no occupied seat because in all directions there's no seat to be seen. Also, people seems to be more tolerant than you expect. So now it takes 5 or more visible occupied seats for an occupied seat to become empty, and more than 4 or more from the previous rules. Right? The other rule still applies. Empty seat does not see any occupied seat will become occupied. And so given the starting layout, it will change. And again at this point it will stop and they will reach equilibrium. So once this occurs, you count 26 occupied seats. Given a new visibility method and the rule change for occupied seats, count again how many seats applied. Right, so now what we need to change is the way that we count the adjacent seats, right? It's not just the adjacent, but in the direction to find it. And also, we need to change the rule where it now takes 5 or more to change it to become empty. So we do that now first, which is 5 or more. And now let's look at the count of adjacent occupied seats. So we actually have a direction, right? So it's just that whether the value itself, whether the seats itself over here is a seat or a floor, right? So instead of doing if, we can actually have a while loop, and we continue a while loop if this direction is actually so once all this is within bounds, we also check whether that cell itself is a floor. If it's a floor, then we're going to continue the loop. And the way to continue the loop is that we update the row direction by adding direction 0 and column direction. Okay, so since we change it, we need to set this as let so that we can update it. And once we reach the end of the thing, let's see, I think better is that, because over here, if after while loop, it could be either out of bounds or it could be not a floor, right? I think an easier way to write this is that we have this check over here. If it's layout, then we continue. If it's else, I think else is any case we have to break. But we need to also check that if that position is at occupied seat, then we're gonna count it, right? So right now, if I believe this is it, and let's run the code. 2085. Whether is that correct? Let's try and see. That's the right answer. Right, we got it. Yeah, so that is day 11, everyone. Day 11. So we have done day 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this is day 11. Right, so if you want to watch day 12, you know what to do. Please subscribe my channel. And if you like day 11 and how I walk through the code, please give me a thumbs up if you like it. And also comment down below that if anything I can improve on. Okay? So see ya. Bye bye.